Stormwater runoff is excessive rainfall that does not soak into the ground, but instead flows into nearby bodies of water due to impervious surfaces. Impervious surfaces are paved surfaces, such as parking lots, roads, sidewalks, and rooftops. Stormwater runoff is a problem because it carries pollutants into nearby bodies of water and causes erosion and flooding. When more than 25% of surfaces are paved, many types of stream life die from the concentrated runoff and sediments.
Green infrastructure is an approach to creating urban space that really looks at the health of the community, the environmental health of the community as well, in other words, trying to restore the ecological balance, and obviously it includes what we do about rainwater, so capturing the rainwater is definitely part of that.
In 2012, the Washington, D.C. metropolitan region installed the most green roofs in North America, with over 1.3 million square feet. A green roof is a vegetative layer grown on a rooftop which helps filtrate stormwater and remove pollutants from stormwater runoff. A green roof consists of a drainage layer, root barrier, growing medium, and vegetation.
Green roofs will absorb about an inch of rain, and they act like a sponge. So both the soil in a green roof and the roots of the tree, the plants in a green roof, will absorb water and will hold it. In the meantime, that inch of water that gets held by a green roof will either be absorbed by the plants or will slowly drain out over the following days. So it really slows down the whole process.
GW has already instituted the G-Water Plan, which addresses rain capture as one of its 8 target goals. As part of this goal, GW wants to increase permeable space by 10% over 10 years and have zero runoff on campus. GW also has installed green roofs on the 1957 and 1959 Eastery buildings, Ames Hall, and the Law Center garage. GW has future plans to install green roofs on the School of Public Health and Health Services, the Science and Engineering Hall, and the Square 77 Residence Hall.
And I do think that this Square 84 Park is a very good example of GW's commitment to green infrastructure on campus.
This unique water reclamation park captures and retains all water that falls on the site. Through a network of cisterns, tunnels, permeable surface, and rain barrels, this 3/4 acre site highlights the technological possibilities for managing stormwater. While GW has already demonstrated its commitment to sustainability, there are additional solutions that GW should implement around its campuses to achieve its goal of zero runoff. One solution is green streets.
Well, there's a concept called green streets, which is a concept that we haven't quite approached at GW yet. And a green street is a street where the street is not given over to cars quite so totally as our streets are today. So that pedestrians, bicycles, and vegetation, wildlife, get a portion of the street as well. And so water can get instead of going into the sewers, can go into the infiltration beds, which can be beautiful. Trees, shade, wider sidewalks, and certainly plenty of room for vehicles, but maybe not parking on both sides of the street and 2 lanes of traffic and so on. That's an example of green infrastructure which will bring a healthy environment for everyone, and I'd love to see that at GW.
In addition to implementing green streets, GW can also take advantage of its current construction projects to replace conventional pavement with permeable ones. This ecologically friendly alternative permits water to soak through the paved surface and be absorbed naturally into the ground underneath. In short, permeable pavement is a self-draining system that reduces flooding and stormwater runoff. Let's pave the way to a green environment.